going to see the how the application can scale from zero to millions of users. And previous session we have seen like how to design and how the backend architecture of the Twitter. And today we're going to see as part of the system design series. Okay, let's back to the topic. uh, so like this is the high level where your application can scale from zero to millions of users. This is a singles. So for initially when our startup is born, this is where you set up your infrastructure. Like it runs on a single server. Everything is running on a one server, like your database, your backend code, and your front end based applications. Everything will be run on the web server. So this is how the typical like design. So like first it will go to the domain. uh, 1 minute. So yeah, it first it will go to the domain name server. This is a third party hosted server. So it get like IP got resolved in the domain name server, and it goes to the backend of our web server. So this is how everything is runs in the single server. uh, but this have some like fallback mechanism. So if this is the single point of failure, if the user has base got increased, so your server will not able to handle the load. That's how today's our topic. So how like any of your dear friend come to you, and he or she has a like startup has born, and now it's a time to like grow into the big tech company. And because of the uh, like like the user base has got increased, so this is a time to like rechange your applications infrastructure, everything. So now everything is running on the web server. Now we are moving our database into the separate server, because we are now separating all our backend code. So typically here in the web server, what will run like web server can handle like server side applications, like your backend code like Java or Python, everything which is running on the web server. Not only the backend, it also takes like your front end based languages like JavaScript, HTML. So those all the code which you are handling will be run on the web server. Now the database having the separate server which will run take care for all our database based operations like read, write, update, or any of the CRUD operations will be take care of the database. Now your database has a separate, because you can handle the load, uh, like it's like you can scale your application. So but when you are separating the database, like what type of database you have to consider, it's like in the discussion, like whether you have to go for relational database or it's a non-relational database. So let's back some discussion. What's the relation database like? So relation databases, you have if you have any tables you have to join, and you have to relation in between your business logic, so you have to go to relational databases. The popular relation databases are MySQL, Oracle database, and PostgreSQL, and so on. And and if you come back to other databases, is like non-relational databases. So non-relational databases have the four categories, like key value pair, graph and column, and document store. These are the four different categories of non-relational databases, and the popular ones are, there are a lot of non relational databases. Basically, it's NoSQL, and we have CouchDB, HBase, Amazon DynamoDB, MongoDB, and Cassandra. These are all like in the market. It's like popular non-relational databases. And so when you have to choose between relational and non-relational, so if you don't have any relation in between your data, you have to go for non-relational. And non-relational is like low latency, it's super fast. And it's not only if you have a if you have non-structure in your data, you can go with the non-relational. And if you have a large amount of data you want to store, can go to non-relational. And yeah, that's it. Like if you have a relation in between your tables and you have to join multiple relations in between your data, you have to go for relational. And relational databases has a historically like 40 years in the industry, and you have a lot of good community. So and yeah, it's up to you which databases you have to choose in between when you are separate in how you have separating your database in your design. So yeah, that's how you have separated your web tier and the database tier. Now let's back to the now the web tier has separated. Now the single server is now we have separated like web tier into the replica. You have added one more web server. Because of the load, it's increasing one server of the web server which you are handling your all your application code which will not be handled. So now you added like horizontally scaling. That means you are added one more server. That's like server 2 you had added. So now now we added the load balancer. What basically the load balancer will do, it will distribute your load to the backend servers. Like now you have server 1, initially it's have only server 1. So now we have come back with the two servers which can handle the load and distributed incoming traffic into the multiple servers. So load balancer. And the load balancer, it's a so so web tiers will connect, the load balancer will connect to the internally web servers with their private IPs, and the public web application or mobile application, their APIs will connect to your public IP of the load balancer. Because this will be in the isolated network. So it will not get connect directly to the like with the private IP. So they are like in the inside of the network. So that's why we have to connect with their private IP of the load balancer. So clients will connect to the public IP of the load balancer. Load balancer will distribute their the load to the different servers. We have a lot of load balancer algorithms like round robin and weighted round robin and IP hash technique. There are a lot of techniques in the market for the load balancer. These are all algorithms. So based on that, so it will get distributed the incoming traffic to the multiple backend servers. And it will be converted only to the public IP of the clients to the load balancer. So this how we will add it. Now we added the load balancer. Now our web tier looks good because now we handle the separated the database. We added the multiple web servers, and we added the load balancer to distribute the load to the different backend web services. Now our web tier looks very good. Now it's time to now we have only the database, and now we have to now it's time to do some work on the database part. So what is the database replication we have to consider? Let's take like database replication is basically it's a master slave architecture. So basically one parent, and we have multiple childs like a master. So all your like modifying operations like write, update and delete operation will go to the master. So if you take the example, if you so the write operation will go to the master data, master DB. And so it will get replicate the data into the child slaves DB1, DB2, DB3. We have three slaves DB. And so all now so the client requested data from the database. So all the read operations will go to the slave DBs, and the write operation will go to the DB, master DB. But the problem here is so So if you have the one of the so if you have a one master DB and one slave DB, and one of the slave DB is down due to some any of the reason, and master so now all the read operation will redirect to the master DB, and once you got like new slave DB got in place, so it will get replaced with the old one, and now after that it all the read operations will go to the slave DB. So that's how so we have a like you can replicate the like if you have any failures occur, you can easily can replace with. And if in case you have a in place, if you have a any time the master DB is down, so that you can consider like slave DB can take the like replica of the master DB. And but this is more challenging because slave DB is not like it will not the like updated data from the master DB. So we have to do some backup recovery scripts to get the slave DB as a master DB, but that's the most challenging. You have to take considering. So we have a lot of technique like in the master DB also we can take it like backup master DB like that, but that's like it's a more complicated. So there are a lot of techniques available. So when you are implementing the master to slave DB, so that's how you can. So now the read operation is super fast because now your slave DBs, it's all the read operations is go to the slave DB, and it is a distributed. How many slave DBs you added, it get all the read operation will get distributed into the different like slave DBs. So all the like read operations from the client is super fast. Only write operation will go to the master DB. So that's how you can implement the database replication in the database level. So this is how the typical uh, your your application look like. So it get client will get to the DNS, it get back to the IP address from the DNS provider, and it go back to the load balancer, and it will internally connect to the web tiers, and web tiers all the write operations will go to the master DB, and all this all the read operations now will go back to the slave DBs. And so that's how your client request will go. Now this is the time to for the cache tier. So basically, what's the cache? Cache is like if you have anything repeated data, you want to like if you have low latency, so you apply the cache wrapper of the database so that any operation from the client, so it will be saved into the cache memory. So and the considerations what you need to take is like when you are applying the cache is like how your data get modified, and how your data getting like reading, how fast your data get modifying. If the data is modifying very frequently, you should not apply the cache. So you have to consider the like some design considerations when you are applying the cache, and also the TTLs you have to place it very like properly. Otherwise you should not be a longer TTL, and the other side it should not be a lower TTL. If you have the longer TTL, if data gets stale, and you will not get the proper data from the to the client. And if you put the low TTL, so it will get like repeated refreshing will happen to the like cache, and that's not the proper way. So you have to consider how the data is modifying in our like database, and how frequently your client is requesting your data from the database. These are the two considerations you have to take before applying the cache to your database level. And let's back to the like we have one more thing we have to apply. That's a content delivery network. So content delivery network is a CDN. So CDN is also the like geographically it is a distributed across all the geographical locations. So basically CDN. So CDN is a third party service provided. So we have a lot of CDN providers in the market, like Akamai and Amazon CloudFront and so on. So you can take the licensing from any of the third party content delivery network providers and the service. So basically, what CDN will do, all our static data, images, videos, and our JavaScript files, CSS, everything from the front end based our static data, you can move to the CDN. So what will happen? So once a user is requesting any of the media content from the web or web application or mobile application, so first it will go to the CDN, and CDN, whether it will check to the CDN is the like file, image, or videos, what other things is there or not. If it is the CDN, so a CDN will be sent back to your web application, and it will not store in any of your backend web service or database. All your static content will be stored into the CDN. And in the CDN also, the providers will apply the, if you see this diagram, so first any of the user A get requested their image.png from the CDN. So if it is available in the CDN, it will return back to the user A. And how the image.png, so like CDNs will give their URLs with their domains to get their images from their system. And the user B is getting same image, so first it will go to the CDN, and it is there, the caching is already applied to the CDN, so that it will return back to the user B with low latency, with quick low latency. And if it is not there in the CDN, if it is not there in the CDN, so it will back to the like your how, where is got stored, because so where is the targeted that images is that stored. It may be in our Amazon S3 or any of our file storage system. So it will go back to, and it will return, and again it will be cached into the CDN. And so what you have to take the consideration when you are applying the CDN. So if the CDN is got basically it will not get like downtime CDN, because so when you take the from the third party like Amazon or from like Akamai, so they have the fallback mechanism. If one of the CDN is down, it will get routed to the different CDN in their available zones. So if you have the CDN is down, you have the strategy to so get your data from your actual storage system. So that's the mechanism you have to apply before applying the CDN. And a CDN is like distributed geographically in the different region. So that's why so basically the CDN is there in the US, like in the San Francisco. The people there in the near to the San Francisco, like in the Los Angeles, they get very fast content when the user is requesting their content from the website. So that's why CDN is distributed across the different regions. So you are in somewhere in Asia, so your request will go to CDN in the network near to your Asian region. So that's why it's a super fast. You can get the all the static content. So that's why all the big tech companies, they move all their static contents to the CDN. So that's how you have super low latency. You can apply when you're having the all the static contents in our website. And so that's how, so now CDN is applied. Now we have database replication. Now we have uh, a load balancer got placed into our web servers. So now everything is proper in the in the design. Now we have to make the consideration of the stateless of our web tier. So what's the basically the meaning of the stateless web tier? So now the user A is requesting some service, data. If you have take any banking application, you have the workflows in the banking application or any of the application. If you take the e-commerce or anything, you have the workflows. Like if you take this example, So you have to transfer some money from user A to user B. So user A enters the from details to details and their amount to get transferred to the B, and that's a workflow. That's a one service, and after that, once the user is getting finish their details, so they need to get to the next step in their workflow. That's entering the OTP. That's the second step in the workflow. So OTP2 you need to enter, then it will go to the like in the final. Once you submit the OTP, that's a third step in the workflow. Once you've done that, the workflow is completed. There are three steps in the workflow. So if you take the like web tier as a stateful, what is the challenges you get occurred in this one? So once user A getting requested from their details, like from and to details to the transfer of money in their workflow, so it may go to the server one. So session data is saved into the user A, and the next service got triggered into the same workflow. That's entering the OTP. So because this is the load balancer got placed, so the request may go to the server A or server B. So we don't have control. So incoming traffic it get distributed across the different servers. So in the user B, the session data is not stored, so it is stored into the session A. Now the user B of entering OTP comes, so the session data is not available in the user B, so your workflow got failed. So what we need to do, we have to take the session data is basically once a user is in the workflow of what is the task they are doing in our website. So they will keep some session data, some TTLs in that. So based on the session data, you no need to again enter all the details, so it is there in the user workflow. So the session data is there, so that now you so now that means the server to have their session data. So and again once you submit the OTP, so the request should go to the server B, but it's not possible. Load balancer can may distribute across any servers. So that's why what we have to do is like you have to take all your session data into the separate storage. It may be a Redis or any of the database, anything. So all your session data will go to the separate storage, so that once a request from the client is getting request from the load balancer, from here first it will go to the any of the your session data storage system. It may be a Redis or anything. It will have some TTS got placed here, so that the session data have some validity. So it may be some shorter because it should not be longer, so it will have some TTL in that cache. So now what will happen is the load balancer will get first go to the session. So if the session is available, it will fetch the session data. Then next it will go to the any of the web server here, so in the web tier. So now the operation here, the operations will get like executed here, so that your session data will be in now in the separate service, so it will not have any impact. So now the advantage of using the session data as separate is like you can horizontally scale your applications. So now now we have three servers. So now tomorrow you have if the user base is getting increase as per your business, now you can increase like 4 to 5 different more web servers you can add. So because now this is stateless, because you are not saving any of our user session data in the web tier. Now your web tier is stateless because the session data is like separated into the separate service. So that's how, if it's storing in the server 1 or server 2 or server 3 of our session data, is the stateful. Now so if you want to horizontally scale your application with adding the more servers, so you have to make it separately separate your session data into the separate service. So that's how in the real big tech companies, so the session data will get loaded from any of the Redis or any of the storage system. So that's how your workflows will work in the web application. Otherwise every time the user need to enter the details. So once he go to the next tab or next work in the next step in the workflow, it's not the proper way. So you have to make your web tier into the stateless. So that's how we have done the web tier into the stateless. Now the data centers, those this is somewhat you can do it from the, if you are having the cloud providers. So basically in the cloud providers, we have the data centers will get placed into the multiple geographical availability zones. You if yeah, you have the users which is there in the US East region, their load get so we have some geo routed. If you see here, this is geo routed. So load balancer can so from the domain names itself. So domain name, DNS can get back to your location based on the IP address of the user, and they got resolved here, and from there the load balancer will get geo routed to the nearest region, because we are in Asia and some people they are in the like in the US East or some regions. So based on the DNS which is got resolved based on the IP of the location which the user has, and so the nearest location, the load balance will get routed to their data centers. So there are multiple data centers available. So uh, if any of the like data center is down, so the cloud providers, so they can so that's the difference between the on-prem and the cloud. You are going for a like any of your applications which you want to grow as a big, from startup to big company. So if you are managing all this is a big challenge. So if you take the any of the cloud provider, so they can do all these things, and they can charge it. So that's the difference. So you don't need to do all this setup. So that's the consideration. If you go with the fully provisionized on prem, so you have to set up all this thing. As I said, this is a big super challenging. So as a startup you are moving to the big tech, so I think you can take any of the cloud providers as a easy solution. You don't need to do manage all these things. And yeah, if any of the data center is down, based on the geo routed, because people are in the Asian region, the Asian region data center is down because of any of the like natural disaster in that data center. So the load balancer, so from the cloud providers, they can route the traffic to the nearest alternative region. So maybe the people who are in the Asian, it got like any of the nearest region, so the traffic will route to the that region. They have some more techniques like like fallback mechanism. If any of the alternative region second backup is also down, they can make to the different region itself. So they have the fallback mechanism. So that's why you have to consider the data center like fallback mechanism. So yeah, that's all. They can take by cloud providers itself. So if you are the on premises environment, you have to take consider. So that's why, like, if any of the so because of this, your application will run 24/7 without any downtime. So logging metrics, yeah, this is logging metrics queues. So basically, queues is asynchronous processing. You have the any large processing in our any large logic you have to like processing in your in our tires web tires. So you can make it as a alternative as a messaging queue. It's a asynchronous processing. So anything, any large data you want to process, which user no need not to wait to their response, you can make it as a messaging queue. So it's like messaging queue is like you can apply any messaging, and so that so you can use it by pub sub mechanism, so it get published and subscriber from any of the other service, and it can process our data. That's how you can, if you want to have implement any of the large scale processing and longer time of some application logics. So it's okay for you if it's not asynchronous. I am okay with the synchronous. You can go with messaging queue. So that's how you can do it here in the messaging queue. And logging metrics and monitorings is so you have to do properly logging in our application. When you are developing your application, so logging plays a major role. So how effectively you do the logging in our application development code. So the people, it may be useful in the different places, like it is easy for any of our production support, like product it's easy for our production support, and the data which you got log, it may be useful for your monitoring, and you can do some business analytics dashboard, and we can do a lot more with the logging. And automation is somewhere you can do with like CACD of your applications, everything, testing, automation, everything you can take consider when your application is moving very big scale. So these are the things you have to consider. This is because this will play a very critical role if you don't do with this proper standard format. So it's not easy once you are moving to the like ever user, if user base is increasing and you have a lot more features to get introduced in our application, and if you don't properly standardize this, it will make a big challenge for you. So that's the thing we have to consider. This is the area we have to take properly, like layout our plan for that. And horizontally and vertical scale, we have talked in the different areas here. Basically the horizontal scaling is like adding the more number of web servers or any of the servers. So like you have three servers when your startup is increasing slowly, and suddenly and user base got increased across different regions very quickly, and like four web tiers is like web servers is not able to handle. You can quickly spin up with the like four more workers, like four more web servers. So that's how the horizontal scaling. So that's the thing we done all these things like stateless, and you have the load balance. This is all pre-work we have already done, so it's now easy to add number of workers to our application. So now there is no issue. Now we have how many workers or how many web servers you can do. Vertical scaling is the other part. Like vertical scaling is like rather than doing like 8 servers here in the one web server, we were adding like CPU, RAM, everything in the one server. But this is okay for when your user base is less. So like your startup is slowly getting increasing. So now we are adding some RAM, some CPU to that worker, but there is a stopper here for adding. We cannot add unlimited number of RAM or CPU to this one worker. So because, and also the disadvantage of this one is like this is a single point of failure. You added like unlimited RAM to the one server is down, so all our application is down. So if you distributed it to the different workers and distributed our RAM or our workers in the instances, so it's a best approach to for urgently when user is increasing very rapidly. But it is okay if the startup is slowly you have the less user base, and I'm okay with our application logic with our slow with the slow servers. It's so that's a vertical scaling you can consider. But if the user base is increasing rapidly, you have to obviously go for horizontally scale your servers. Database sorting is basically you like so basically inside the database you are adding the multiple so you have the four shards, like four databases you are placing. So basically how the logic you have to implement the shardings here is like, so basically from the incoming user id you just divided by like what is the value you can divided like the percentage by 4 the value which you are getting. So based on the value it will get to that database. And from the same time when you are reading the operation from the client, same thing, the same calculation will calculate based on the shard value you are getting from the client. So from there it will get the request will go to that particular shard, and the request will get. So this like it's like a multiple sharding, so that rather than keeping all the data in one place, you are splitting the multiple databases and you are storing it. Like you have a 0 to you have like 1 lakh or 10 lakhs of user IDs. So you can keep like 0 to 1 lakh is one shard. So all the 0 to 1 lakh users will be in the shard 0. From 1 lakh to 2 lakhs all the users you are keeping into the shard 1. From 2 lakh to 3 lakh it's in the shard 2. From 3 to 4 lakh it will go to the shard 3. So rather than keeping all the 10 lakhs of users into the one database, you are making in the splitting, and you are segregating all the user base. And the difference between here the shardings and the master to slave is like inside the master or slave db you have multiple shardings you will apply. So you have the one slave db, in the slave itself you have multiple sharding. So that's the difference between master slave and the sharding techniques you have to implement when your user base has is increasing drastically. So it's like one database is not a ideal. You have to split your user base, and you have to segregate your user base, and you have to implement the sharding techniques and the master slave database designs, so that your reliability and your reliability will be like, and the fallback mechanism like failure will be the less. And if you have a low latency of the client from the client, so that's how you have to implement. So yeah, that so these are the some key considerations you have to take when your startup is like moving to the big scale tech company. So all this is key considerations you have to work around, solutions you have to do before migrating from a startup to the like moving to the so large scale big tech application. So yeah, this is all about from the uh, like, so the concepts you have to take, like we'll go back one, like single server database, load balancer, and database replication, and cache tier, and content delivery network, stateless and stateful web tiers, and the data centers. So this can be taken by cloud providers. So logging metrics and automations, and the queuing mechanisms you apply in our applications, horizontal and vertical scalings, shardings in our database. So these all you have to take consider. And yeah, I think so these are the things you have to take consider. And if you like the content, please like, share, and subscribe to my channel. And we'll see you in the next interesting topic. Thank you. Bye bye.